Hello friends, welcome to the Formula Engineering classroom again. And in this lecture we will discuss a special topic. In the last lecture we discussed about the hydrostatic force exerted by the fluid on the submerged bodies. In this lecture I will discuss the point of action of hydrostatic force, that is also defined as center of pressure. So obviously in last case we discussed that is the force exerted by a fluid on a submerged body can be formulated or can be calculated by the use of the formula that is F is equals to WAYC. Here W is the specific weight of fluid, A is the area of the submerged surface, and YC is the distance of center of gravity of the body from the free surface of fluid. Now this force is acting at a point, and that point is defined as center of pressure. So that point is defined as center of pressure. This is center of pressure. Okay, so what is this one? Center of pressure. So let's suppose I'm considering a vertical flat surface here. Okay, and this vertical flat surface is submerged in some static fluid, and this is the center of gravity of this plate here, and obviously in this case this is YC, that is the distance of center of gravity of the plate from the free surface of fluid. And let again here, just a minute, this is this part here, and this fluid is I'm taking here, so this part is this one, so this is the leveling here. Okay, so the variation of pressure over this plane surface, vertical plane surface, is like that. It looks like this one, as we discussed in the last lecture. The pressure is varying like that over this vertical plane surface. Now, so we calculated the force exerted by this fluid on this flat surface is F is equals to WAYC. Now this force is acting at a point that we define center of pressure. So what is the center of pressure? So obviously if we are considering a body over here, and let the weight of this body is W, so we know this weight of this body will act from the center of gravity of this body. Okay, now as this force is exerted by the fluid, in that case this force will act at a point due to this pressure intensity diagram, and we can say that that point will be the center of gravity of this cage. Okay, but this is a bit confusing, so let first we defined it in different way, and we defined this one by the use of principle of moments. And according to principle of moments, it said that there is component of moments or sum of components of moments about an axis will also be equals to the moment created by the total force about the same axis. So what is the sense of this statement? So let's suppose here we are considering again, this is the free surface of fluid, and here is some vertical plane surface. This is the front view, this is the side view, and we discussed this case in our last lecture. Here we are considering a strip of area dA which is acting at a distance y below the free surface, and in this case this is our considered strip here. Okay, that I'm taking here is the CG of this plate or surface. This is the center of gravity and distance is yc. So over here again we can show the pressure distribution. It looked like this one. Okay, now so the pressure intensity at this strip, which is y distance below the free surface, obviously we can say that this particular pressure intensity will be rho g y. Okay, so due to this pressure intensity, the elementary force that is acting over this element we can say that is elementary force dF will be equals to the pressure intensity, that is rho g y, and the area of the strip, that is dA. So we can write this one, this is W y dA. Now so this force, this elementary force is acting normal to this surface or normal to this element. So when this is acting normal to this element, so this will create a moment about this free surface of fluid. That if I'm saying this is OO. Okay, this is the free surface of fluid. So this elementary force that I'm applying, this elementary force normal to this one, and I'm writing this is dF. So this dF is acting normal to this dA. So due to this dF, which is at a distance y below, it will create a moment about the free surface, and we can say that there is that elementary moment dm will be equals to the elementary force and the distance of elementary force from the free surface, that is y. So this is the elementary moment created by this elementary force about the free surface. So we can also write this one. So force is W y, there is also y here, so y square dA. Okay, so this is the elementary moment. Now we can consider number of strips here, and definitely the position of that strips will be different from the free surface of fluid, like y1, y2, y3 and all these things. So the total moment over the surface, plane surface, about the free surface, we can find out by integrating this one. So we can say that there is moment m will be equals to integral dm. So here we can write this is, so w is constant. Okay, now this y square is also variable because the strip distance from the free surface is different. dA is also variable, so we can write here that is integral y square dA. Okay, so now in this case this is the total moment. Now this particular term, that is integral y square dA, is termed as second moment of area, and we also known as, this is defined as moment of inertia. So we can say that there is integral y square dA is moment of inertia. Okay, so this is moment of inertia. So we can write this one is equals to I O O. Obviously this moment of inertia is about this free surface, or we can say this is axis OO. So I'm writing this is IOO. This is about OO. So we can write this one. This will be equals to M is equals to W, that I'm writing for the simplicity IO. So this is our first equation. So according to principle of moments, the sum of the elementary moments about an axis, that is this one, will be equals to the moment created by the total force, that is this one, about the same axis. Okay, so let's suppose if I'm saying this force F is acting at some point here, and I'm defining at this point is center of pressure. I don't know where it is, this point, where this point, and over here the total force is acting, that I'm saying this is F here. So obviously we can say here this is at this point the total force F is acting. Okay, now let the distance of this point from the free surface of fluid, that we are saying yp. Again, we don't know how much is the yp, but we are simply saying let there is some point here, that is we are defining center of pressure, and let distance of this point center of pressure from the free surface of fluid is yp. So this total force is creating a moment about this free surface, that will be equals to the force F multiplied by the distance from the free surface, that is yp. So I can write this m will be equals to total force F into yp. Okay, we know this F is equals to WAYC. Okay, so we can write here WAYC, and this is yp. Okay, now from the principle of moment, the sum of moment about an axis, that is m equals to wi naught, will be equals to the moment created by the total force about the same axis, that is equals to WAYC yp. So these two equations 1 and 2 are equal according to principle of moment. So we can write here this will be equals to WAYC yp will be equals to Wi naught or IO, you can say that. So from here we can write what is yp. So obviously this W is out here, so this yp will be equals to I naught divided by AYC. Okay, now as our previous knowledge and from the parallel axis theorem, let to understand the parallel axis theorem, I'm drawing here is an axis. Let this is axis 1 1, and let there is some body here. Okay, or let's suppose this is the center of gravity of this body, and distance of this one from this axis 1 1 is that we are saying this is y bar, and let area is a here, and let this central axis we can say this is xx, this is yy. Okay, so from the parallel axis theorem we can say that there is area moment of inertia of this plane surface about the 1 1 will be equals to, so I 1 1 will be equals to Ixx, that is moment of inertia about the self axis, plus area and y bar multiplied by the y bar square. This is according to parallel axis theorem. Okay, so now we can notice here this I naught is the area moment of inertia of this plane surface about this axis OO. So we can write this will also be equals to moment of inertia about the self axis or central axis, that is I am writing that is IC, plus area of this plane surface and square times of YC, that is square of YC here, because YC is the distance of this plane surface or center of gravity of this plane surface from the free surface. As you notice here this is y bar, so here it is YC, so we can write this is YC square. This whole term is divided by AYC. So you can notice here this I naught is the area moment of inertia of this plane surface about the axis OO, that will be equals to the moment of inertia of this plane surface about the self axis plus area multiplied by the YC square, that is the distance of center of gravity of this plane surface from this free surface. So by simplifying this one we can write that is yp is equals to, so this is AYC square divided by AYC, that is YC, plus IC by a yc. Okay, so this is yp. So what is yp? Yp is the distance of center of pressure from the free surface of fluid. And what is center of pressure? Center of pressure is the point of action of this total hydrostatic force or total pressure force. Okay, so this is the center of pressure distance from the free surface of fluid. So what we can conclude from this one? So first of all, we can see here, that is, the moment of inertia of a body about self axis will always be positive. It's obvious. And area, this will also be positive. Yc is also, we are taking the depth, this is also positive. So means the whole term, that is Ic by Ayc, will always be positive. Will always be positive here. So if this term is positive, in that case we can see here, that is Yp will always be greater than Yc, because this term is positive. So means the center of pressure where the total force is acting will always lies below the center of gravity of the body. Okay, that is Yp is always greater than the Yc. That means the center of pressure of this total force acting point will always lies below the center of gravity of the body. Second thing, let's suppose this body is going to continuously sink down in this fluid. So when this body is continuously sink down in this fluid, then obviously Ic remains same, because Ic is the moment of inertia of the body about the self axis. So this will remain same, and area of the body will also remain same. It's not going to change, but Yc keeps increasing. You can see here, when this body is going to be sink down here, then the distance of center of gravity of the body will also increasing from the free surface of fluid. So means this, as Yc is increasing, then the whole term Ic by Ayc is going to be decreased. As Yc increases, then Ic by Ayc is going to decrease. So in that case, when this term is going to be decreased, in that case the center of pressure, that is Yp, is going to be closer and closer to Yc. Means the center of pressure will always try to approach the center of gravity, but they will never be coincide to each other, because there is only one chance when the center of pressure of this force, that is where the force is acting, in that case when Yc is going to be infinity. So as the Yc is going to be infinity, in that case this whole term Ic by Ayc is going to be 0. In that case Yp and Yc will be equal, means the center of pressure and the center of gravity of the body will be coincide, and obviously Yc can't be infinity. So we can conclude that, that is, as the body is going to be sink down continuously in fluid, the center of pressure will try to approach the center of gravity, but they will never be coincide here. So this is the center of pressure. Okay, and we can calculate the value of center of pressure from the free surface, or distance of center of pressure from the free surface, by calculating Yp. Okay, in starting I told you, that is, this center of pressure actually is the center of gravity of this pressure intensity diagram. I'm repeating again, that is, center of pressure is center of gravity of this pressure intensity diagram. So how this is possible? So first we will check the center of pressure by using this formula, and then I will show you, that is how I'm saying, that is, this center of pressure is center of gravity of this pressure intensity diagram. So just a minute. So this is our free surface. Okay, and let's suppose I'm considering this is our plane vertical surface, and the top edge of this plane surface is exactly at the free surface of fluid. Okay, now let width of this plate is b and height is that I'm saying h. So in this case, here is the center of gravity, and obviously this is yc. Okay, this is yc, and in this case yc is equals to h by 2 as the top edge of this plane surface at the free surface of fluid. Now the pressure variation on this plane surface is like that. Obviously I'm drawing this diagram again and again, but it's necessary to understand the concept of this topic. You can understand easily by using the 3D diagrams. Okay, now so first of all we can calculate the hydrostatic force. So obviously the hydrostatic force in this case I can write that is that I'm saying that is hydrostatic F force will be F is equals to WA YC. Okay, so this force is exerted by this fluid over this surface. So here area of the plate is B into H. Okay, now we want to try we will try to calculate the YP. So let's suppose around here is YP. Obviously I discussed that is YP or center of pressure will always lies below the center of gravity of the plate. So that this is the center of pressure. Okay, and let's suppose this is the total force acting over here. This is that F. This is acting at the center of pressure. Okay, so let first we try to calculate what is YP. So obviously in this case we are saying this is our YP. So we know the formula. So well, I'm writing again. YP is equals to YC plus IC by AYC. Okay, so what is YC here in this case? Obviously YC in this case is H by 2. Okay, what is IC here? So area moment of inertia of this plane surface about this self axis. So this is a rectangular body, we can say here. So about this axis we can say the area moment of inertia will be equals to BH cube by 12. BH cube by 12. Okay, area is equals to B into H, that is area of this plate. So YP, will be equals to YC is H by 2 plus IC is BH cube by 12 and area is BH and YC is H by 2. Okay, so here B is out, so this is H square, so this is out, only H is there, so this is 6 here. So we can write this is equals to, by simplifying this one, this is H by 6, and by simplify this one we can say this is 2/3 of H. Okay, so this is 2/3 of H, that is our YP. So our YP is 2/3 of H. Okay, so you can see here YC is H by 2 and YP is 2/3 of H. Obviously this is YP is larger than the YC. Now I told you that is this center of pressure is center of gravity of this pressure intensity diagram, or this case, yellow case here. So you can see here this is a triangle. Okay, this intensity diagram is a triangle here, and I think we know for a triangle, from the apex of this triangle the CG will be 2/3 of the height of the triangle. You can see here that is the CG of this triangle will be 2/3 of its height from the apex, and you can see here the yp is also equals to 2/3 of h. Okay, so as I told you, that is the center of pressure is the center of gravity of this pressure intensity diagram. You have to remember always this thing. You can simplify the rectangular bodies by using this formula directly here. Let's suppose if this plane surface top edge is not exactly at the free surface, like in this case. So in this case, this is has some distance from the free surface. So obviously in this case, the center of pressure will be the center of gravity of this trapezium. Okay, and the total force will act over here at this center of pressure, and you can calculate the distance of center of pressure by using the formula, that is yp is equals to yc plus ic by ayc, or in case of rectangular body you can directly calculate by calculating the center of gravity of the pressure intensity diagram. Obviously in other cases you can also calculate by calculating the center of gravity of pressure intensity diagram, but in that case the pressure intensity diagram will become complex. So in that case you can use this formula directly. It's better and it's a time saving. Okay,